Okay, so we've seen how we can evaluate integrals using U substitution, integration by parts. We can use partial fraction decomposition. We're going to take a look at a couple other techniques we can use to evaluate integrals. Hey, we're going to look at integrating using inverse trigonometry, but it's a little less straightforward than what we might have seen in the past. So if we look at this thing here, we can see that it kind of resembles the derivative of inverse tangent, which is 1 over 1 plus x squared. So we've got the 1 on top. We have something squared on bottom plus 4. So we need to turn that 4 into a 1. So we can factor out a 1/4. That gives us x minus 3 squared over 4 plus 1. X minus 3 squared divided by 4 is the same as x minus 3 over 2 all squared. So this is 1/4 inverse tangent of x minus 3 over 2 times 2, since we have to account for that 1/2 there being squared, multiplied by that reciprocal. So it took a little bit of manipulation, but we were able to get it into a form where we could take the antiderivative. Here we're going to see how we can use the method of completing the square. So we're going to complete the square in the denominator. Half of -6 is -3, squared is 9. So we could have that as x squared minus 6x plus 9 plus 4. And we can factor that square, as you can see right here. And it turns out this is the problem that we just did. So again, we factor out a 4th, simplify that squared term on bottom, and take the antiderivative. So what we have here now is just a couple more tools in our toolbox. If we see that we have the integral of a fraction, we might try using partial fraction decomposition. If that doesn't work, we might try using division and rewriting it, or we might try using completing the square to get it into a form where we can use one of our inverse trig functions. So you just have to kind of go through and process the information you're given and think to yourself which of those methods might be the most likely to help you get it into a form where you can take the antiderivative.